Alright guys, now we are looking at our target 3.5 mastery learning objective. I can use properties of tangents to solve problems involving circumscribed polygons. Okay, so it's involving tangents, so we want to know what a tangent is. And a tangent is a line that hits a circle at exactly one point. Okay? And where it hits the circle we call the point of tangency. We're not going to worry too much about that. But that is a tangent line. So something like this, see, it hits it at 1, 2 points, not tangent. Okay, and a lot of lines can be almost tangent, where it just like crosses through just a little bit, like here and here, right? But they're still not tangent. A tangent line is a line that hits it at only exactly 1 point. So, the first theorem that we have for today is our tangent theorem. And our tangent theorem states a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangent, C. So line L is tangent to S. Sorry, line L, this line, is tangent to this circle if and only if this is a right angle. So again, tangent lines create right angles. That's really the biggest part. So let's look at example 1, how we're going to use this. Assume segments that appear to be tangent are tangent. So that will happen a lot. So for example, what is the measure of, wrong thing. What is the measure of angle ROS? Right, that angle. Well, I'm assuming this line is tangent because it looks like it is, and therefore this line creates a right angle. Now this is a very easy triangle angle sum problem. 35 plus 90 plus x equals 180. Adding up these, 125 plus x. 55. All right. Same thing here, except it looks like our T got cut off. We're gonna put T here. What is the measure of angle TOU? Well, same thing. We're solving for x. Angle T to O to U is this angle here. O is in the middle. And again, same thing. This looks like a tangent line. So we're going to say it is, because that's what this means. And so since that's a tangent line, that's a right angle. Then, same thing, right? 90 plus 23 plus x, right? Adding all three of these, again, since that's a triangle, it'll add up to 180. Just combining these, we get 113 plus x equals 180. If I were to subtract, 67 degrees. Okay. So let's look at our next type of problem we might encounter, knowing that that is possibly a right angle. Okay, or that is a right angle. This one says determine whether the segment is tangent or not. So we're trying to decide, is this a right angle or not? And how we're going to do this is using that converse Pythagorean theorem problem, or that idea. We looked at this a little bit with our KC2, right? We can use Pythagorean theorem to solve for a right angle or to check if it is, right? If the Pythagorean theorem works, then it is a right angle. one thing to be careful with these is this is 8, and that 8 is a radius. This side's 15, and then this is 9. That 9 does not go the whole way. But this is also a radius and is therefore 8. Meaning this whole side is 9 plus 8, which is 17. That's the biggest trick to these problems. Okay, is knowing that we have to put our other radius there, right? There's sneaky radii everywhere in these problems. Now I can do a squared plus b squared equals c squared. Our hypotenuse is across from the angle we're checking that's a right angle. The other two are a and b. Eight squared is 64. 225. I probably should know what 17 squared is, but I don't. 289. Then I'm just going to add these up. 64 plus 225 is 289. Does equal 289. Check. So, yes, KL, this line here, is tangent to circle J. Okay. So because the Pythagorean theorem worked, this is a right angle, and if this is a right angle, then this line is tangent. Next one. Same idea, right? This is our radius. This side is 8. And then again, this little piece is 12, right? And so then this side is, this radius is also 6, meaning this big piece is 18. Okay. Then again, we're trying to check if this is a right angle. That's supposed to be a question mark, but it didn't really work. So a squared plus b squared equals c squared. 6 squared plus 8 squared should equal 18 squared. Equals 18 squared is 324. And then 36 plus 64 is 100. Which does not equal 324. So no. This is HG is not tangent. Okay, so if it works, yes, it is tangent. If it doesn't work, no, it's not tangent. All right, let's look at our next activity. Example 3, find the value of x. Assume that segments that appear to be tangent are tangent. So same type of thing, okay? So again, now we're assuming that this is tangent, so I am going to assume that that is a right angle. Well now, same thing, I have this right triangle. This is, if I know that's a right angle, this is an easy Pythagorean theorem problem, okay? So I have a squared plus b squared equals c squared. I'll say a is x squared plus 14 squared equals 17 squared. 14 squared is 196. This was 289. Right, 17 squared is 289. If I subtract 196 from both sides, I get x squared equals 93. and I take the square root, x equals the square root of 93. That has no perfect square in it. So x equals the square root of 93. Easy enough. Part B, same thing. Well, kind of, right? This is touching that circle once, so this is a right angle. Okay. But now you have to be careful, right? This is x, which means this is x. But then this whole side over here, right, I go x and then 2. That's x plus 2. Similar to the triangle things we did in KC1, right? We have to be careful. And now we have to be even more careful. So here's my right angle. So this is A and B. So we have x squared plus 4 squared equals, this whole side is C. And that means I have x squared plus 16. X plus 2 squared is x plus 2 times x plus 2. This is the part people get wrong the most. They want to do that x plus 2 squared is x squared plus 4, and that's not right. I have to FOIL, or distribute twice, or the boxes. Right? Some teachers teach it like this. Whatever you learned last year, that's what you have to do. Okay? So a lot of us learned FOIL. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. So now we have x squared plus 16 equals x squared plus 4x plus 4. One thing, if I subtract x squared from both sides, because there is an x squared on both sides, I get 16 equals 4x plus 4. I kind of move my work over here. Now I just have to subtract 4 from both sides. I get 12 equals 4x. Divide by 4, x equals 3. So those are a little bit longer with having to have an x squared on both sides. So be careful that if you see something that looks like this, you are foiling it. Alright, our last problem is these exterior tangents problems, and that's a new theorem. If two segments from the same exterior point, exterior just means it's outside of our circle, right, are tangent to a circle, then they are congruent, okay? So both of these are tangent, so that just means those are equal. Easy enough. So example 4, find the value of x. Assume that segments that appear to be tangent are tangent. So again, both of these come from B. And they hit our circle in one spot. And so therefore these are the same. So that means x plus 15 equals 2x minus 5. I'm going to subtract 2x. 1 minus 2x is negative 1x plus 15 equals negative 5. Add, subtract 15. Because they add 15. That's not right. Negative 1x equals negative 20. Divide by negative 1. X equals 20. And that's it. Those are easy enough, and we've seen a lot of problems where things are equal before. Again, we don't have to memorize it, so easy enough example. Have a wonderful weekend, and I will see you guys on Monday.